Assalamualaikum and greetings to Dr. Nurfahana Hassan. We are students from JCDCS 1103H, and in this video, we are going to present the application of the Venn diagram in real life. Beforehand, let me introduce you to my teammates first. We have Nurin Irdina, Muhammad Affan, Lubawi Nurhilman, and me myself, Izzah Sofiya. The four of us team up to finish this assignment together. So, in this video, we are going to talk about the introduction to a set of theories and Venn diagram, the description concept of Venn diagram, how we apply the concept of Venn diagram in real life, and our summary based on what we have learned by doing this assignment. First, the introduction of set theory. Set theory is a branch of mathematical logic that deals with studying sets, which are collections of distinct elements. In set theory, a set is considered a well-defined, unordered grouping of objects, and these objects can be anything, for example, numbers, letters, or even other sets. There are a few elements and key points in set theory, including sets, elements, subsets, unions, and also intersections. Sets are collections of distinct elements. Sets are typically denoted by curly braces, and the elements are listed inside. For example, given here, the set of natural numbers less than 5 can be written as 1, 2, 3, and 4. Okay, furthermore, we have subsets, where a set A is considered a subset of another set B if every element of A is also an element of B. This relationship is denoted by A subset B. Furthermore, there's a union where two sets are a new set containing all distinct elements from both sets, denoted by A union B, while the intersection is a new set containing only the elements that are common to both sets, denoted by A intersect B. Next, the introduction to Venn diagram. A Venn diagram shows the logical relationships between two or more sets of items by using overlapping circles or other shapes. We can apply the elements and keys from set theory in Venn diagram like the union, intersect, and others. Venn diagrams can be drawn physically using circles or other shapes to represent sets and their overlaps, visually showcasing relationships between different elements or groups. They frequently help to visually arrange things, emphasizing the similarities and the differences between the objects.
Okay, so I will explain about description of Venn diagram concept. A Venn diagram. In Venn diagram, it shows a rectangle for the universal set, circle inside the rectangle for various set, and distinct point for elements. The number of elements in a region is represented by a number that is not punctuated at that location. Circles that overlap each other share same characteristic, while circles that do not overlap do not share same characteristic. Also, Venn diagram assists us in illustrating the contrast and similarities between two concepts graphically, so that it is convenient for us to understand. In a Venn diagram, every circle itself symbolizes a set which could be made up of concepts, ideas, things, or numbers. The shared subset are referred to as union or intersection when those circles overlap or intersect. Differences between sets arise from areas that do not overlap, and everything that is not shared by a certain set or subset is referred to as complement set. Okay, so before we look into example of Venn diagrams, a Venn diagram shows different set operation such as the intersection of sets, union of sets, and difference of set. And there is 4 common or major operations in Venn diagram, which is complement, union, intersection, and difference. So as we can see in the slide, there are some symbols that are used in Venn diagrams. Okay, so how do we use these operations in Venn diagram? For the first operation, which is complement, for the subset A of universal, the complement of A is denoted by universal subtract A or A complement. We can see the shaded region in figure 1 represent A complement. For the second operation, which is union, the union of sets A and B, denoted A union B, is the set of all the elements that are in A or B. The shaded region in figure 2 represents the set of A union B. Okay, next is the third operation, which is intersection. The intersection of sets A and B, denoted A intersect B, is the set of all elements in both set A and set B. So as we can see the shaded region in figure 3, it represents set A intersect B. And for the last operation, which is subtraction, is known as the difference between set A and set B. Is the set of all elements that belong to A and do not belong to set B. We can also write difference and subtraction in the symbol as A/B as set A subtract B. And mathematically, this operation is equal to A/B or A subtract B equal to A intersect B complement. So as you can see the shaded region in figure 4, it represents set A subtract B.
So the next one is applications in real life. We try to relate the sets of theories by using the application of the Venn diagram to determine the uses of Spotify playlist among students in UiTM Segamat. There has been 3 playlists with genres of K-pop or known as K, ballad as B, hip hop as H, and users can choose a maximum of 3 playlist genres. There is a total of 2,500 users of Spotify among the students, which can be divided by 1,545 users who choose the K-pop playlist, while 1,235 users choose the ballad playlist, and 980 users have chosen the hip hop playlist. And we found out that 110 users enjoy all the 3 different genres, while another 130 users do not prefer all 3 playlist genres. Supposedly there is 500 users choose K-pop only, and 230 users choose hip hop only. So for the first one is ballad. 1,235 equals to A plus B plus D and plus 110, which is 1,125, which is identified as number 1. For the next one is K for K-pop. 1,545 equals to 510 plus 110 plus B and plus C. It is 925, which is equal to B plus C, which identified as number 2. So for the next one is H for hip hop. 980 equals to 230 plus 110 plus C and D, which is 640 equals to C plus D, identified as number 3. So for the total of the whole Venn diagram, which is 2,500 equals to A plus B plus C plus D plus 110 plus 510 plus 230 plus 130, which is left with 1,520, consists of or equal of A plus B plus C and plus D, which we identify as number 4. So we let number 1 into number 4, which is 1520 equals to 1125 plus C. Then we get C, which is equal to 395. We substitute the value of C inside the other equation. So 640 equals to 395 plus D. And we get D for 245. And 925 equals to B plus 395. We will get B for 530. We will substitute the value of B and D inside the one equation. So the 1125 equals to A plus 130 plus 225. A equals to 350. The next one is can be seen figure 1.2, which is consists of all the numbers that we have calculated. So the next one is process number 2 and number 3. For the second question, we can get the answer based on our past calculation and the Venn diagram that had already been drawn in figure 1.2. We will convert the question into a representation of set operation, which is B intercept H equals to 245. The answer is 245. Users choose ballad and hip hop. Next one is 1520 equals to A plus B plus C and plus D, which we identify as number 4. And for the third question is we can also refer to the figure 1.2 and convert the question into a representation of set operation, which is K union B minus H, which is equal to 510 plus 530 plus 350, and we will get 1390. So the 1390 is the users who have chosen K-pop or ballad, but not hip hop.
Then we proceed to the process 4. Next, for the last question, we want to find the most preferred playlist genre among the students. There is a list of the total of each genre. As shown, 1545 students have listened to the K-pop genre. Then, 1235 students listen to the ballad genre. Meanwhile, only 980 students listen to the hip-hop genre. As we can see here, the most preferred playlist genre among the students is K-pop, which has 1545 listeners. Then, we can convert the value to a percentage to see a clear view of the differences among these three genres. 1545 divided by 2500, which is the total of all the students, then multiply by 100 to find the exact value in the percentage, which is equal to 61.8%. Hence, the percentage for the most preferred playlist is 61.8%. Next, we proceed to the conclusion of the application in the Venn diagram in real life. In conclusion, Venn diagrams are versatile and powerful tools that find widespread application across various disciplines, visually representing relationship and intersection between sets. Whether used in mathematics or statistics, Venn diagrams offer a clear and concise way to illustrate complex concepts, identify commonalities, and distinguish differences. It is a universal tool for visualizing and understanding relationships among different elements or categories. This application of the Venn diagram offers the user a valuable visual representation of music preference within this specific community. Lastly, with its fundamental framework for logical thinking and problem solving, set theory illustrated by Venn diagrams play a vital role in forming a mathematical understanding. The capacity to analyze real-world scenarios is improved by the ability to describe the complicated interaction through set and their intersection. This highlights its ongoing relevance of set theory and Venn diagrams in aiding in a deeper understanding of a variety of phenomena. That's all from our group, and Assalamualaikum.